on the dais, Negi Saab, and other, my, say, colleagues here. First of all, I just want to thank you for Negi Saab, because I have been associated with him since a long time, since my parent company, Gail India Ltd, and later on. And see, his expertise in that since beginning, they have all, helped me actually build what I am today. And one thing I must tell that these experiences, that learning from experiences, that when Negi Sahab muted this session, and he asked me to present something on my expertise. Of course, my expertise is, of course, now I have widened. Since a pipeliner is a pipeliner, and in a Gale, it's a pipeliner is a pipeliner. Although my background is electrical engineering, but pipelines, integrity management, and the cathodic protection. So that was my field, and CIMG, that is a Central Integrity Management Group, that is specifically made for integrity of our pipelines. So I was a part of that. And Negi Saab is very much particular about the presentation, quality of the presentation. He revised my presentation 2-3 times. I liked it. Nobody did it. Nobody does it, actually. But he did it. He asked me that first thing, you make it within 10 minutes. And secondly, you hit the bull's eye. Okay? That is to the point. So I have made, and in my presentation, 80% contribution is Negi Saab's, 20% is mine. Technical is mine, but the shaping of the things because of his suggestion. So I thank you again. Now, before I start my presentation, I must tell KV Singh is here. He is doing a lot of job on this AC interference, AC fault, lot of fault analysis. He talked about the CGD. CGD is now more exposed to this kind of interference and say the fault problem. So there are two problems in AC interference. One is your AC interference that leads to the corrosion. It's a slow process. And another is the immediate fault condition, which result is immediate, like KV Singh told examples. And this is very much frequent in CGD because of its complexities of the pipeline. Tiwari talked about the oil pipelines 2017, that it was due to AC interference. Though I doubt it was AC interference, but interference leads to corrosion. So whether it was a corrosion loss or it was the fault loss. These two things are different, the conditions are different, process are different. So he told about 128 days. So that is around 4 months line service. In 4 months line service, how much current was there? Is more, say, study is required. How much was the AC current density, and whether that can lead to this type of pipeline rupture. I think that there may be some fault condition at that time which led to this abrupt puncture of the pipeline, that intensity. That is a further study is required. Now, I will talk about, say, gas line, 2015. So, KV Singh talked about CGD in 2025. We are still back to square one so far as AC interference, AC fault condition is concerned, particularly to CGD. I am not talking about the cross-country pipeline. Tiwari told about 2017. So that was still people were not knowing about AC interference. Otherwise, this problem would not have occurred. I am talking about 2015, 2 years before that, when also all sort of this knowledge about AC interference or the AC modeling, which is now very much there, it was not there. And this is also one of the example of, if everybody is telling about the company, so I should also tell, of course, this is my parent company, okay, Gail India Ltd. I was part of this investigation. So this is the case study of, I must tell you, the pipeline that was a VSPL, Vizag Secunderabad LPG pipeline. So there was a case of AC interference there. So I will just go because time is short. So this is the facts of the incident. So these are the pipelines, So diameter 12 inch, I need not explain, but the important thing is that, say, year of commissioning, this year of commissioning was 2004, and type of coating, year of CIPL DCBG 2012, interference survey 2015, year of ILI 2015, and year of dig verification 2015. The AC interference corrosion was observed only by the inline inspection in 2015. Up till now, there was no monitoring, no mechanism to detect AC corrosion or do any sort of, say, mitigation measures. This is the fact of the case. This is the AC interference. This data is important. So 220 kV parallel 7 kilometer line. So the parallelism length is more susceptible is your AC interference and AC corrosion. So 7 kilometer. Distance of tower from pipeline, this was 100 meter. Now they are talking about 25 meter. Even the Canadian study says that even 100 meters, these are the, say, average. Susceptibility of AC corrosion is there. So you have to go around 300, 500 meters as far as you can go. Of course, it is not possible now. But if it is possible to such pipeline away from the transmission line, you have to go. This is the fact. Then soil sensitivity low, AC voltage 4 to 6 volt, sufficient to cause at 1000 ohm centimeter AC current density of more than 100 ampere per meter square. That is going to have a AC corrosion. So DC current density was low, zinc anode resistance was more than 5 ohm. This says it should be less than 5 ohm. So earthing was not proper, and AC current density was higher than 100 ampere per meter square, not following your standards. So this is the same fact as I told you. Important thing is that running 7 kilometer, tower footing 100 meter, low soil acidity 100 ml per meter square, pipeline was cathodically protected, nothing to do with the AC interference. Polarization cell was not able to bypass, otherwise 4 to 6 volt you would not have got. So this was not operational. Metal loss was observed between 25% to 40% in the AC interference area. That was known by the dig verification and the ILI. So type of corrosion is indicative of AC corrosion. So a lack of awareness of the personnel. K.B. Singh was talking about the competency management, very important. I don't know whether still people are aware of the phenomena of AC interference, AC corrosion. Why they take place? Okay, otherwise they would have taken some rectification measures. Now in CGG, so 220 kV line is going on top of your pipeline and you don't have any rectification measures. You cannot move your pipeline away from the transmission line, but you can have rectification measures. You can ground the fault current. Why it should go up like that when there is a more than coating stress voltage? So that is the way of knowledge of standards. What does they say? What does the latest Canadian studies say? You have to follow that. So CIPL survey they have done, but nothing. AC current density, AC voltage, they have not measured. Okay? Corrosion probes were not installed. Still, many places they have not installed. They can give you the reading of the corrosion loss at that point. So, and you have to do the DCBG survey to know your say, coupon, how much thickness loss is there. So this is one. So these are the site images. So rust formation, actual site information. VSPL, because I went to the site, I saw them. So this is rust formation, this is metal loss. Thank God it was 40% loss and pipeline was safe. They repaired it by using the clock spring. That was a warning, but that would have been upgraded if they would have taken the preventive measures. This is again the same circular metal loss, typical of that. And you can see this. This is coming out of bulging effect here. So mitigation measures, again, they have changed all those things. So I mean to say minor coating and repairing of the minor coating in that interference area. That is very important. So normally we do CIPL CAT. See, if it is nearer to that AC interference zone, you have to repair it. Don't leave it. Because the minor coating defect increases your AC current density. This is one thing. So grounding a pipeline, zinc anode, that passivates. It does not work in the long term. So replace it by the copper conductor cable along with the solid state decoupler. Again, it will cycle. So KV Singh ji gives the example, 120 milliseconds. It was 1800 milliseconds. If pipeline could not sustain 1800 milliseconds before their breaker gets off. So what is your cycle? You are taking 30 cycles per second. That is 0.6 seconds. That is 600 milliseconds. Don't rely on electrical authorities. Their breaker may not flip, but your pipeline may get damaged. Okay? Go for the 3 cycle or 5 cycle current and the 10 kiloampere, 220 kilovolt, 10 kiloampere. 5 kiloampere at 600 milliseconds, will it be safer for your pipeline? What is the specification of HSDC and your grounding electrode? All these things you have to know. What precautions you have to take. So this they have taken, okay? So this is the decoupler with grounding device. This is just CP coupon and corrosion coupon you have to install. So this is the grounding system, solid state decoupler. See how much specification I have given. 3 cycles, 1600, 4500, 6800 ampere. You can increase. You should know how much is that fault current. Accordingly, you design. This is the bare copper conductor packed with carbon backfill for grounding. So don't rely on zinc anode. That is not for your grounding. So this is preventive measures. Same thing. You can read. So this is the monitoring part. Okay? How much we are doing. So grounding resistance semi-annually, AC voltage, AC current density semi-annually. Now you can have a coupon. You can measure AC current density. Okay? Then polarization cell, 2 monthly. And if you do all this monitoring, check, and online monitoring is available, remote monitoring. You got all the data, so you can be vigilant. So this is the conclusion. Same thing. Thank you. And before I conclude, I just want to introduce my book, Cathodic Protection Principle and Application. This, I have written this book to know more about DC interference, AC interference, troubleshooting, all sort of things. If somebody wants this book from me, they can take. This is available in hard copy as well as in soft copy. Thank you for patient hearing.